Hi everyone. Welcome to this weekend webinar series on Azure. The title is, as you can see, Serverless and AI Fun with Azure. It's based on a true story. About me, my name is Gurucharan. I work as a software engineer at ABB on an IoT stuff, actually the Internet of Electric Vehicle Chargers. Outside of work, I co-chair the Azure user group in Bangalore. We are around 3,000 people. We meet regularly, and I blog at gurucharan.in. I started it recently. So yes, like I said, it's a true story. So I will this whole meeting will go exactly as it happened. So yes, so Build 2019 happened somewhere around May, and at Build, Microsoft demoed a lot of features at their headquarters, which I like to call it as the Redmond Reality Distortion Center. They demoed a lot of things. One which really caught my eye was they had something called the conversation transcription. It was primarily about a bunch of people joining a meeting. It was them demoing conversation transcription API where they said if a bunch of people are talking in a meeting, you can get real-time transcripts and who is talking about what. So that was interesting for a demo, and I wanted to try it out for fun on a weekend. So I was looking around the documentation and realized that conversation transcription API requires a custom hardware module and SDKs installed inside of it. While that was not uh, feasible for a weekend project, going through, I realized and I saw that there was something else called a batch transcription API, which we will have a look at. So before that, let me take a step back and explain all the different features of Azure Speech Services and where all these APIs come into picture and how we are going to use them. So Azure Speech Services has three major components, the first of which is a speech to text API. Next is the speech translation, and the third one is text to speech. So speech to text, as the name suggests, you submit an audio file and you get text. Speech translation, again, as the name suggests, it's translated. Text to speech is you give in text and then you get an audio file of the voice that you choose. We are going to look at only speech to text now. And inside the speech to text, there are multiple offerings. One of them is a real-time audio transcription where you use their SDK and, for example, use your device's microphone and keep consistently talking and you will get semi-real-time transcripts. Next one was the conversation transcription, which I referred to earlier, where it's it's more suited to a meeting scenario. A bunch of people in a conference room talking to a microphone or a custom hardware device that has the right SDKs and right software installed. The third one, or the one we are going to have a look today, is what I would say is the batch transcription API. The batch transcription is it's a perfect scenario for something like a call center or where you have large bunch of audio files and you want to transcribe them not real time but in bunch at a later stage. Batch transcription is perfect for those kind of scenarios, and it can transcribe files of these extensions WAV, MP3 and OGG. So let's see how we can get started with Azure Speech Services and more specifically the batch transcription API. So you go to the Azure portal, you search for speech, and then you get this and you hit create and then you choose a name for your API and then you choose a subscription and then you choose a resource group, location, and that's all. So it's as simple as that. I've already created one, and here you can see that it's called AZ Podscribe Speech YNB, a naming convention that I've decided to choose. And you would see that there is an endpoint here and you can get keys. So important thing to understand is you create a batch transcription API, you use these keys and you make HTTP requests to the transcription endpoint. But a gotcha here is that for batch transcription, this is not the exact endpoint that we are going to use. If you look at the documentation, they would say that the batch transcription API is the region.chris.ai. I created the speech services in the West US region. So you would go to westus.chris.ai. And here you have, this is a Swagger page, and here you have custom speech endpoints. So how do you make a request? This is the endpoint, and we see that it was speech to text v2 transcriptions, get a list of transcriptions. So let's see if we already have existing transcriptions. The, the content type you set as application JSON, and you have to set the speech key which you get from here. I have extension installed that would kind of mask my keys, but this is exactly what you copy and you paste it inside Postman. I have it stored in an environment variable. So you get results that look something like this. Before you get a result, you have to know how to submit a transcription. Yes. So let's look at that endpoint. Exactly the same endpoint, you make a post request, and then this is how the JSON looks like. You need a URL to the file and then some metadata around it. The models is if you have a custom trained model that you want to use, for example, specific to your domain or specific to your accent and your industry, then you can use the models. Otherwise, Microsoft's default model is used to transcribe speech. You choose a local, this is mostly US, and a name and an optional description, and then how do you want the transcription results to be. Profanity filter mode is when you use swear words or profane language. How do you want the results to be? Do you want it masked or not? Punctuation is the same. Is it capitalized? Do you use punctuation marks? And do you want word level timestamps and sentiments? Let's have a look at all this. Before that, sorry about that. Before that, we need a recordings URL. Yes, we need a link to an audio file. If you look at the speech services documentation, it would say URL of the Azure Blob. So I need to have a URL, a publicly accessible URL of a blob in an Azure storage account. So to do that, let me use the Storage Explorer and maybe upload an audio file. Let's wait for the audio file upload to finish, and till it uploads, let's listen to what this audio file is. This is from the movie Fight Club, which is the intro dialogue. So the audio file upload is complete, and now you need a publicly accessible URL. The best way to do that would be to generate a SAS URI, and then you get generate SAS signature. Permission to read would be enough, and there is the SAS URI is valid for 1 day, and then you hit create. You copy, you go to Postman, you make this request. Before that, let me type it into the browser and see if the URI is indeed valid. Yes, we get an audio file, so this URL is a valid public MP3 file. It's here, and so let me hit submit. So the result is you get a 202 status accepted, and like I said, not like I said, as a 202 is, it's not immediately the result is available, but it's accepted for processing. And where do you go to see this result is you have to look in the headers, and then they give you an ID. So you go to get transcriptions, put in that ID here, and then hit send. You get the recordings URL. You will see that the results URL is still empty. This is the model that was used for transcribing. This is Microsoft's own speech to text model. And then you would see when was it created and what is the status. You get the name, you get the description and all the results, as you can see. But let's wait for this to finish. But I have a similar thing already transcribed, so let's look at that. This would be the first one, this would be possibly second, which is already succeeded, and it's the same file, fightclub.mp3. So let's look at the ID for that. Let me hit send. Oh, okay, mistake. I copied the ID of the model, which is not exactly what I have to copy. I have to copy the ID of the transcription request. Copy, paste, hit send, and here you see. So it gives me a results URL, which let me try to access. It's a JSON, and then you get the entire audio transcribed. When another thing to note is when I made a transcription request, I said add word level timestamps is true. So for each word, you get an Unix timestamp. And now they've added support for doing it in seconds also. Before it was not there. And if you realize this entire thing, while it's not 100% accurate, it's a good enough transcript. Sorry. So we saw how to create an Azure Speech Service. We uploaded a file to the Azure Blob storage. We generated a SAS URI. We submitted a transcription result, and we submitted a transcription request, and then we saw the results. One quick thing that I would like to cover here is also the fact that how long does it take for a transcription to get finished? Let's see if this is finished by now. It still says not started. So usually it takes as long as the audio file itself once it has started. So for a 5 minutes audio file, the transcription takes somewhere around 5 minutes once it has started. But when it would start is not something that we can control, because we don't expect results to be real time anyway. Since this is a batch, this is something that we have to learn to live with. Also, they have another thing where you can register a webhook once the transcription is complete. Let's look at how the documentation explains that. So when a transcription completion event happens, you can register a webhook so that you get notified that the transcription request is completed, and then you can parse the results instead of keeping polling the endpoint for whether the transcription is completed or not. So we downloaded an audio file, uploaded it to storage, posted a transcription request, and then we got the results. This is good for one file, but when you have a large amount of files, this can quickly get an extremely tedious manual process. So can we do this programmatically? And if we do this, what is the best way to do this on Azure? So downloading an audio file. Let's assume we have a steady link to an audio file where it gets updated automatically. So once we have that, downloading an audio file is as simple as using any HTTP client and then giving a link and then storing the file as a stream or storing it locally on that processing machine. Uploading it to storage, again, Azure Storage provides enough SDKs. If there is not an SDK for the language that you are using, best way would be to use this HTTP APIs itself. Get SaaS URI, like again, it's the same, the SDK is supported. Once you get a SaaS URI, you can post it to the transcription endpoint. And once because we've registered webhooks, once the webhook is registered, you can get a response at a URL that you specify. And once there is a transcription completion event notified, so you can pass the results. So best way to do this on Azure would be, let's see if we can do it on serverless. Serverless computing is just in time servers. So code is run on demand on magic servers when something happens. Serverless is not about lack of servers, it is no servers for you to manage. So before I show you anything advanced on serverless, let me take some time to explain the basic concepts behind serverless computing, at least on Azure. So every Azure function has three things. So there is a function app which you can run in the serverless plan. Every function app has an Azure function, has multiple Azure functions, and each function has a trigger, an input binding, and an output binding. So what is a trigger? Trigger is when you specify when my app must run. When something happens, run this. Yes, the trigger is that something happens. When I get a HTTP request, when something is uploaded to a storage account, when there is a new event in an event hub, things like that. So input binding is what do you want to do. Input and output binding specify what do you want to do when the trigger happens. So when a new file is there, take that file and store it in Azure storage. In that case, the input and output bindings, while in that case, the output binding is Azure storage while the input binding is nothing. So this brings us to another concept where the trigger is mandatory, but the bindings are optional. So when a new file is there on Azure storage, print hello world. Perfectly valid Azure function does nothing where you have a trigger, but you don't have any input or output bindings. So if we have to do this workflow in Azure Functions, how would we do this? So the first one, download audio file, which means let's assume somebody is made available a list of links to audio files. So whenever there is a new audio file, which is the trigger, and then you have to upload it to Azure storage. In that case, the binding would be input binding is nothing, and the output binding would be the Azure storage account. Again, you can ignore the output binding and write code to write it to Azure storage all by yourself, but output bindings reduces the amount of plumbing code that you have to write. The next one would be, sorry, the next one would be after something is there in the Azure storage, get a SAS URI and submit that to transcription endpoint. So in this case, the trigger would be Azure storage and the input binding will also be Azure storage, but the output binding would be actually nothing, and you make an HTTP request to the transcription endpoint. The next stage is you have to wait for the transcription results to complete. And when the results is complete, because you've registered a webhook, the speech transcription API will make an HTTP post trigger on your webhook. So there the trigger is HTTP and your input and output bindings. Your input binding would primarily be you read the results. So you have no actual input binding, but it's simply you reading the results, and the output binding is where you want to store it. I'm not going to uh, explain the output binding for this scenario. We'll take a look at it a little bit later. So in that case, what we've done now is we have an audio file link. Let's assume we have that link. So we make an HTTP trigger, which is a JSON request on HTTP post about links to the audio file and other metadata. So we can write the first Azure function, which saves it in the blob storage. The next one is a separate function where when something happens on a blob storage, when there is a new MP3 file in a blob storage or a new WAV file in the blob, do something. So what is the something? It would be submit for transcription. Now this brings us to an important question. Where can we get a good source of conversational audio that we can use to test our system? The answer for that would be podcasts. Podcasts are a fantastic source of quality, professionally recorded audio conversations that we can use to test if the Azure's transcription API is really good, and if it's good, how good is it? You have multiple podcasts, but how do you get links to a list of all the episodes inside a podcast? In that sense, the answer would be to use an RSS feed. While when I was initially building this, I didn't start or end with any big ambition. I was seeing how I can do something with Azure serverless, and I did not realize RSS feeds can be used in this manner. I was deciding to do something called like a web scraping, where I go to uh, each link and scrape for an MP3 and input that. But RSS feed saved me a lot of time. And which is my favorite podcast that I use for this? You know this gentleman here, I assume, Scott Hanselman, very popular. He hosts multiple podcasts, one of which is Hansel Minutes. And let's see how we are going to use Azure Logic Apps to get the feed items from Hansel Minutes. So if you're not sure what Azure Logic Apps is, Azure Logic Apps is a workflow enterprise business connector system. It's a serverless designer first business workflow integration service. What does that mean? So if you know how to draw a flowchart, Azure Logic Apps can automate all the intermediate steps inside the flowchart. Let's take a look. So yes, whenever there is a new audio episode, and let's look at what's there in the Hansel minutes.subscribe. So you get the RSS feed for the entire podcast. Get individual items, title, description, and links to the audio files. So let's go back to creating a logic app. So when a new item is published to the hanselminutes.com/subscribe RSS feed, I wanted to make an HTTP call to somewhere else. This is a demo webhook simulator that is available for free online, which you can use to test it. But the real interesting situation here is although there is an RSS feed, there is no kind of a push notification kind of system available. Why, if you have an RSS feed, you also need an RSS client that is kind of polling the RSS feed to check for updates, and that client can give you notifications. But RSS by default is not a notification system. So I check here every 3 minutes to see if there is a new feed, which is not ideal because I know for sure that Hanselman updates his podcast once every week. Also, because this needs to manage state in the sense I need to know only the new items, which means I have to know what items have already been processed. And while I was building this, testing it became a real pain because I can only the RSS feed is updated only once in a week, and if I have to write multiple tests, it was very difficult. So I was looking around to see if I have my own RSS feed and that I can control at a cadence that I have, and I found something very interesting. There was a person who wrote his own RSS feed just for the similar purpose. This is an RSS feed that can update at your cadence. For example, an RSS feed that updates once a minute. So this I can use it to test, but how? Let's see this test designer. So I have this flow where whenever there is a new RSS feed item in my lorem RSS, which I would check every 1 day or 30 minutes or however often I want. Let's assume I check for every 1 minute. What do I want to do? Now, this is exactly how I used to test my system, but in other scenario it kind of makes no sense because when I have an update in this RSS feed, I'm asking list all the items in the Hansel minutes RSS, and for every item I ask the system to make an HTTP request to here. So how I would test it is I would host an Azure function which listens for an HTTP trigger, and this was making requests here. Initially I got it to work well, but this RSS feed is the RSS connector for the Azure Logic Apps is not something that I control. So in that sense, it was giving me certain edge case scenarios. So now we have a system that looks something like this. You have an RSS feed and you have an Azure Logic app that checks the RSS feed for updates. You check it however polling frequency that you want to choose, and then whenever there is a new feed item, you then continue with the workflow that you need for the batch transcription. Now the question is where I have the results, but I need to store them somewhere. What do I use on this side? I decided to use at first to use Cosmos DB to consider whether it would be a good option, but The thing I realized is that Cosmos DB, while it is a globally distributed NoSQL multimodal database, it's kind of an overkill for this scenario where I simply want to store a bunch of JSON transcripts. While the rest of the system was really serverless in a true sense because you pay for only the execution time in a logic app. It's the same with all the three functions. And for the cognitive services, you pay $1 per hour of transcription. So if you're not using the cognitive service, you don't pay for it. The storage account is a very minimal fee, but the Cosmos DB was a little bit expensive for me, where it cost me at least $25 a month minimum, and then you have throughput costs. So, like I said, the Cosmos DB was a real expensive item for me, so I have to replace this with something slightly more cheaper. And once I have an alternative that is slightly more cheaper, I can then build a web application, a simple ASP.NET Core or even a static application that reads the transcripts from my storage and syncs it and plays it along with the audio. That was how I finally wanted to finish this. I decided to use GitHub as a sort of my persistence mechanism where once I have the transcript audio, I push it to GitHub and commit it there straight. What this allowed me what this allowed me was a chance to also take community contributions for transcript audios because the transcript audios are not going to be 100% accurate. Storing it on GitHub and use leveraging Azure Speech Services to automate part of the process. It is a kind of best of both worlds where you use artificial intelligence and the strength of it to generate an 80% to 90% accurate transcripts, and then you use the human expertise to go to the final 10% to generate a perfect 100% accurate transcripts. While storing it on other persistence mechanisms also made sense. For example, I could have used the storage accounts itself and store it on a blob storage. Storing it on GitHub meant it's available for public and people can make pull requests and all changes would go in, audited and reviewed. While I was doing this, there was something that I did not anticipate was that Hansel Minutes has been a podcast that is running for around 10 years now. So which means there are 52 weeks in a year into 10, which is 520 weeks, and each week he launches about 20-minute to 30-minute audio, which is 200 hours of audio, which could cost me somewhere around $200. And I did not realize that. So once I built this kind of system, I triggered this and went to sleep, and I was ready to wake up the next day to see how much transcripts I have and what issues I might face. I got a weird email that your subscription has been disabled. Thankfully, this was not a fully pay as you go subscription. So while subscription was disabled, I did not have to pay this entire huge bill. Again, something that you might want to think about. So let's see how we do this GitHub directly committing to GitHub, and we'll also show you some code around the rest of the Azure functions. So this is the Azure function which you can create on a Visual Studio, going File, New Project, and then you choose an Azure function, you hit OK, and then you choose what trigger you want to use. You can also do this outside of Visual Studio if you're using a Linux environment or a Mac, where you can download the Azure function CLI and do it on the command line also. Let's wait for a quick minute for Visual Studio to launch. So there was another design decision. Some things that the sort of people always ask me is, why are there three separate functions? Can you not have one function that does everything? And the answer is, like any nice answer in software, it always depends. So when I built it, I wanted to break each function to do one thing and do one thing well, so that I can have multiple entry points into the system. For example, if you are going to give me links to audio files, I can enter via this HTTP trigger here and directly make post request to this HTTP function. While if you have RSS feeds, I can entry via here. And for some reason, if I don't trust you with my audio file, but I ask you to I want my audio files to be stored in my storage account, and I will give you only SAS URIs that you can use, then I can enter via the function here. So while I did not design with all these entry points in mind, it's something that you can also take away. So Visual Studio has opened, and let's see. So this is the on RSS feed updated Azure function, which is this one here, which is this one here. So what I do is I just deserialize the HTTP post request that I get and then store it in Azure storage. Another interesting thing was, whenever the audio file had a slash in its name, it used to store it inside a folder in the Azure storage. So yes, this was something that I found initially difficult to manage, and so I have a kind of crude way to fix it, that I have to find a better way to deal with this. Next function is this one, where once there is a blob trigger, what happens? On audio uploaded to storage. Again, very simple. You would see that there is an Azure function and which is triggered by a blob, and it takes only star.mp3 files. So if there is a file uploaded to this blob storage which is not an mp3 file, this function is not triggered yet. All I do is generate the SAS URI and then make a transcription request to the speech API endpoint. I set the headers the right content type, and I make a request to speech to text transcription endpoint, which is the exact same thing that we have here, or rather here. The next thing is on transcription completed. Again, this is again an HTTP trigger where it's a post, and all you have to do is first I was have it stored in Cosmos DB, and then I synced it to GitHub. But the only thing you need to do is use the GitHub's AutoKit API, which you can get from the NuGet package AutoKit, and then you have a bunch of steps where you generate a path token and store it in the headers, and then you create a commit via these steps. The steps are straightforward from and it's simple from the documentation, but there is no one API for you to call and hit commit. There is a list of steps that you have to do. So yes, how does this scale? Like I said, the rest of the entire thing is serverless, except for, let's say, the Azure Cognitive Service, which you can use to transcribe up to 20 concurrent requests per second. So should I quit my job and start a startup or something? Yes and no, because right now I look at commercial transcript offerings in the system or in the industry, and nobody offers this kind of workflow. None of them have anything like an RSS feed, and none of them give you automated results. Most of what I see is, send me a link to an audio file or upload an audio file, and tomorrow I would email you the transcript results. While some of them are fully automated and artificial intelligence powered, a bunch of them where a bit of human involvement was needed. Coming to costs about commercial transcriptions, some of them can cost as high as up to $1 per minute, while Azure Transcription gives you transcripts that are accurate for $1 per hour. So what do I want to do with this? While I started it as a fun project, it kind of seemed to be somewhat useful. And here I do not have the flexibility of just uploading partially files. So here I want to have two entry points where there is, to avoid this huge cost thing that I showed about, where you can transcribe past episodes if you want, but otherwise it's only transcribes new episodes. Also, if you look at the transcripts, it does not tell you who spoke what. While Azure Transcript Speech Services recently introduced support for speaker segmentation, which is, it wouldn't tell me Guru said this or person B said this, it would simply say A said this, B said this. It would not know who you are, but it would kind of use maybe a voice frequency to identify it is, then this is a different person than the other one. Azure Speech Services now supports only up to two speakers, and while I tested it on Hansel Minutes, which is mostly two people speaking on a podcast, it was not, the results were not extremely great. So maybe I would choose some Python libraries, audio analysis or something like that, run inside an Azure function or maybe a container to do speaker segmentation. This is how I plan. So before that, let's have a look at a quick demo of how the end result looks like. This is a website that I have. It's called Hansel Minutes Plus Plus, and I transcribed like 40 to 50 episodes from his podcasts. So you can click on play, and then you would have, this is running on a free plan in Azure, so might be slow. So you can play a podcast and the transcripts are automatically synced along with the audio. So the key takeaways is how you can use serverless as a powerful programming model for event-driven applications. And the next big takeaway is, while I did not know anything about how to do artificial intelligence, how to build my own models or train my own models, I can understand and appreciate the APIs that Azure offers and easily build on top of them. So much so that I could have a offering that is competent in the market on a paltry budget and on a weekend. Again, if you want to take a look at it, this would be the slide. I have written about it at Hansel Minutes Plus Plus. There is a live demo that I showed you. An entire source code is open source, and this slide deck is also available at speakerdeck.com. Credits for these logos would be Ashley, and the slides are inspired by Zach Holman, who has a bunch of nice speaking tips at speaking.io if you want to try it out. That would be it from me. Thank you.